Hello everyone, Johnner, and I'll be talking about what I learned in Control Engineering Laboratory. So for this semester in ECE3211L, or Control Engineering Laboratory in short, I learned many important concepts about control system stability, transfer function, and control design. At first, many topics looked difficult, especially the mathematics behind poles, zeros, and system response. But through experiments, MATLAB simulations, and reaction videos, I gradually understand how control systems actually work and why they are important in engineering. So, which is approximately also increase keberhasilan niya hasilin on ramp. While pulls far to the left, have minimal effect fluctuated and stabilized. So for underground, the settling time is about 6.80. I also realized that controller tuning is very important because incorrect gain values can lead to oscillations and instability. Overall, depending on your configuration. That's all. Thank you. And the video was very helpful because it also explained that not all step response look the same analysis and design. So this video was very helpful because with a simple solution. The video explained this using a drone, for example. It cannot eliminate steady state error, but why each component is needed. From videos A to I that I watch, which provided by Sir, I learned that foundation of control theory and how engineers use control systems in real life applications. I learned that control systems are everywhere, such as in robotics, drones, industrial automation, vehicles, and even temperature control systems. I also learned about transfer function, which mathematically describe how a system reacts on an input. Stability was another important topic because an unstable system can become dangerous or unusable. The videos about PID control were especially helpful because they explain how proportional, integral, and derivative control work together to improve system performance. I also learned designing a control system is not only about making it fast but also stable, accurate, and efficient. So, in the early experiment 1 to 4, I learned the basics of transfer function and time response. I learned how to derive transfer functions from differential equations and verify the results using MATLAB. I also studied system responses as overshoot, rise time, peak time, and settling time. Another important lesson was system stability. I learned how poles and zeros affect behavior of a system. A system becomes stable when the poles are located in the left half plane, while a stable system has poles in the right half plane. This experiment taught me that even a small changes in the pole location can significantly affect how a system behaves. So in experiment 5 and 6, I learned more about performance specifications and root locus analysis. I studied how damping ratio affects oscillations and overshoot. I learned that increasing damping makes the system more stable but slower, while lower damping makes the systems faster but more oscillatory. So for root locus, I learned how pulse moves as the gain K changes. This helped me understand how engineers tune system to achieve the desired response. So MATLAB became very useful because it allowed me to visualize the behavior of the system instead of only solving equations manually. So in experiment 7 and 8, I learned controller design using root locus and PID controllers. So for root locus design, I learned how compensators and added zeros can improve system performance. I saw adding how I saw how adding zeros change the I saw how adding zeros changed the settling time and overshoot of the system. In experiment 8, I learned about PI and PID controllers. I understood that the proportional term improves speed, the integral reduces steady state error, and the derivative term helps improve dampening and reduce oscillations. So comparing PI and PID controllers helped me realize that there is always a trade-off in control system design. Faster systems may have higher overshoot, while more stable systems have respond slower. So one challenge I encountered in this subject was understanding the mathematics behind poles, root locus, and transfer function. At first, MATLAB and SISOTOOL also felt confusing to me. And however, through repeated experiment and practice, I became more confident in interpreting graphs and understanding how systems respond. As future engineers, one important lesson I learned is that control systems are not just equations. They are practice tools used to make systems more stable, efficient, and reliable. So overall, this subject helped me better understand how engineers design intelligent and stable systems in the real world applications.